All right. What's up, my gangophiles? Today we're going to do some homework for Calculus 2. Heck yeah. So first we got problem 1, displacement versus total distance. Object moving along a straight line, velocity, let's write that down. T squared minus 4t plus 3 from 0 to 5. Okay. Direction changes 5 times in 0 to 5 when the object changes direction. Explanation, clearly state what it means for the object to change direction. Okay, so I guess we'll factor first. So t minus 1 and t plus 3. Or, wait, no, that'd be t minus 3. Minus 3. And so, let's make a sign chart here. So at 1, and then at 3, so let's take a point from 0.5 and then plug it into original equation. So 0.5, so, okay. Positive. And then let's plug in 2. So 4 minus 8 plus 3 is a negative. And then, so plug in 4, that is 16 minus 16 again. So positive. So go from positive, negative to positive. Explanation, clearly state what it means for object to change direction. In terms. Yeah, so it would be moving forward from 0 to 1 because it's positive, and then moving backward from 1 to 3, and then moving forward again. After 3, right? I think so. And then, so just changes direction at t equals 1 and t equals 3 trace. And now, displacement, compute the displacement of the object on the interval 0 to 5. Write your answer. Now, since we're given the velocity equation, we can just, I think we can just take the integral of velocity from on that interval, which t squared minus 4t plus 3 dt, which is t over 3 to the third minus 2t squared plus 3t. I think I did that right. And then if we plug that in, so 125 over 3 minus 50 plus 15. Okay. And then plug in 0, 0. That'll just be 0. So minus 0. And then, what is that? Okay, I'm going to calculate that, I guess. 125. 5 divided by 3. 41 point bunch of 6 minus 50 plus 15. And then let's turn that into a fraction. Here. So 20 thirds. 20 thirds. So that's that. There's number 1. Total distance traveled. Compute the total distance traveled from on the interval 0 to 5. Make sure to explain why you must split the interval if needed and show setup using the absolute value. Yeah, so you're definitely going to have to split it up, though, because of the sign chart. Wait, why am I doing that? Because of the sign chart. Here, let's get rid of this real quick. Because we already know that. And we'll do number 3 up here. So the total distance would be the integral, because it can't be the integral velocity. I think it'd be the integral of the absolute value. Wait. I think that's right. Split interval at 1. Distance is okay. So yeah, I guess it'd just be absolute value that would be speed for sure. And then so if we split that up, so we go from 0 to 1 of the velocity, and then we do from 1 to 3 dt, and then we add that final one, which would be from 3 to 5. Okay, yeah, that makes sense, I think. And then let's move over here. F, so the integral, which we already have, would be, where did I write? Okay, there we go. So let's just write this back out. But over here, and then let's plug in f of 1, so 1/3 minus, so then of 0, just 0, so 4/3, and then so that is from 0 to 1, and then we evaluate it at 1 to 3, which would be plug in 3. I'm just gonna put it in the calculator. Negative 4/3 absolute value Wait, yeah. So there's 4/3, I think. And then let's plug in 5. 5 minus 3 in the equation. So 20/3. Shoot. 20/3. And then we just add those. And 28/3. Look at that, all same denominator. And then, what's number 4 say? Concept check, short explanation. In 1 to 3 sentences, explain why displacement can be 0 while total distance cannot be 0. Because displacement is like how much it's moved from the origin, or yeah, how much it's like the distance from the origin. So if it moved a bunch and then came back to the same spot, the displacement would still be 0. And then total distance is just how much it traveled in total. So it would count however much it went and however much it went back. That's why you need the absolute value. That's what I was thinking. Okay, there is number 1.